Hi people, good evening. So only Venetia and Divya are here. Yes, you're able to hear me, right? Hello? 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 Hey guys, are you able to hear me? I think now it's working, I guess. Can you just confirm, Venetia or Divya? Can you please confirm that you can hear my voice? Okay, thank you. Thank you, Venetia. So we'll just wait for a few more minutes. Let your friends join and we'll start. Okay, if you have your friends' number, please text them and ask them to join soon. In Pranav, you might have someone's number.
So can you repeat, sir?
No, I'm asking, can you just text or call your friends and ask them to join soon? Can you
Sir,
have the
one
number?
second, sir. Like your voice is not audible. I'll just connect it like some other headphone.
Sure.
Yeah, yes, sir. You can tell now.
What I'm asking is, if you have your friends' number, can you just please text them or call them and ask them to join soon?
Okay, sir. I'll just call them now.
Yeah, sure. Thank you. So 4 of you are there. So we'll start. Okay, let your friends join whenever they want to join. Okay, so let me share the screen. I think you have to make me host. Chitra ma'am, are you there? Like, I think you have to make me host. Yeah, yeah, correct. Oh, okay. Yeah, nobody is host. Yeah. It's just a moment. I think there is some issue with making me host. Yes. Okay. Yes, ma'am, I got it. Thank you. Cool. So okay, we'll start. Right. So, so we have been seeing about intermediates, right? So I think we even saw how to decide acidic strengths, basic strength. We just saw inductive effect. Hope you remember, right? So tell me what and all you remember about inductive effect. Hmm? What do you remember regarding inductive effects? What are the applications? Okay, fine. I'll ask question by question. So tell me, in what cases, or tell me what are the conditions in which inductive effect can be visualized? What is the condition? Hmm? Hope you're all able to hear me. Right. So yeah. So I'm asking, what is the condition for inductive effect to persist? Yes, someone try to answer. Okay, fine. So the thing is, guys, you need to have a polar bond, a CX bond, or whatever it is, right? So you need to have a polar bond. That should obviously be, the thing is that you should have a partial negative charge on the higher electronegative atom and partial positive charge on the higher electropositive atom or the lesser electronegative atom. Right? That is the condition. Right. So let me start with some questions. Then I think it will be better. Okay. Fine. So, mm, fine. So let me ask you. Say if I have Fine. So right. So if I have these two carboxylic acids, right? Now tell me which is a better acid, which is a stronger acid. First or the second? I hope you're all there. I give you two acids and I'm asking you which acid is a better acid, a stronger acid? So yeah, I think everybody's there. What happened, guys? Okay, fine. Let us do a guess game then. Right. So how many of you think first one is a better acid? It's just a guess. At least now you can open your mouths. How many of you think first one is a better acid? You can even put it in the chat box. Okay, fine. So Rahul says one. Fine. Pranav says I'm not sure. Okay, others, quick. We don't have much time. Okay, fine. Rohan says one. Cool. So guys, tell me, what is the concept behind if I want to decide acidic strength, if an organic, if I give you an organic acid, right? Now, what is that criteria which decides that that is a good acid? Awfully quiet today.
So
Okay.
I have a doubt.
Yeah.
So in the first one, there are 5 bonds in carbon.
There are, oh, okay. I understand that. You just have to remove hydrogen here. Okay, now it's fine. So yeah, so okay, Bhavadani was saying something. What is it? Did you miss last class or something? Okay, no issues, Bhavadani. No issues. Okay. So yeah, so okay, so on some of you said first one. Okay, before we see what is the answer, what is the concept? How do you decide whether this acid is a strong acid or a weak acid? Based on what? Based on what? Okay, is it that you forgot or you don't want to answer? What is it?
So is it about that alpha hydrogen, sir?
That will work for alpha hydrogen that is coming for tautomerism. Yes, there is acidic in that case, but how did you prove there that, okay, this can give me H plus? How will you prove it? Someone should remember. How come no one remembers? Someone should remember. Okay, does it have to do anything with stability of something? Stability of what? Okay, so I suppose you don't remember as such, I guess. Fine. So I don't like, please remember this, people. You have to decide whether a given acid is strong or weak. It depends on the stability of the conjugate base. Hope you remember, right? At least now it should ring some bells, right? So the acidic strength is directly proportional to the stability of the conjugate base of that particular acid, right? Okay, now what is the criteria for stability with respect to inductive effect?
So what did you ask now, sir?
I'm asking, okay, we know this now, right? Stability of an acid, sorry, the strength of an acid is directly proportional to the stability of this of its conjugate base. Okay. Now, what I'm asking is for stability, what is the criteria with respect to inductive effect? How did you say that a tertiary carbocation is more stable than secondary and secondary is more stable than primary? Based on what?
Based on its charge, sir.
Correct, right? So please understand, stability is inversely related to the amount of charge the species possesses. Okay, more and more neutral it is, more and more stable it is. Right, so this is how you decide. So if you can easily, okay, hope you know what is the conjugate base. After removing H plus, whatever is remaining is what is called as my conjugate base, right? So whenever acids are given to you, right, and they ask you decide the acidic strengths, the order of acidic strengths, first thing you have to do is remove the H plus, right? You have to remove, what you have to remove is H plus, right? Okay, now you will have this negative charge on this oxygen, right? So now tell me, where do I have wherever I'm going to have lesser charge, there it's going to be a more stable conjugate base, and that particular acid will be a stronger acid. So now what is your answer now? Where do I have lesser charge? First or second? Someone I think is unmuted, but they're not talking. Please speak, whomever it is. Where do I have lesser charge? Okay, chlorine is what kind of group?
In the second one, sir.
In the second one, there is lesser charge, you're telling? Okay. Fine. Cool. So please understand, guys, chlorine is an electron withdrawing group. Right? Here also I have chlorine, here also I have chlorine. Right? So chlorine is an electron withdrawing group. That means it is going to withdraw electron towards itself. Right? So if it is going to withdraw electron, the negative charge on this, and obviously the negative charge on this is decreased, no doubt. Right? Say if I compare it with this compound, right? Say if I compare it with right, if I compare it with both of these with this compound, this acid, propanoic acid, right? So you will easily understand that here I don't have any electron withdrawing group. Basically, I have only electron donating groups. I told you all alkyl groups are electron donating in nature, right? All alkyl groups are, guys, just give me a moment. So yeah, so what I was telling is if you compare this particular acid with these two, right, here what you see is only electron donating groups. All alkyl groups I told you are electron donating in nature, right? And you have, whenever you have electronegative elements like fluorine or bromine or OH or amine, something like that, right? So all these are electron withdrawing groups. Okay, so if I just remove this H plus and make a negative charge here, right, you will see that the negative charge would have been increased because of the presence of this alkyl group. Correct, right? But because I have a chlorine here, right, and here, right, the amount of negative charge will become like little bit decreased compared to this compound, right? Now the question is, among these two, right, where is the charge amount of charge to be less? Yes, now you want to give me an answer? I told you that inductive effect is distance dependent, right? So closer electron withdrawing group or electron donating group, which whenever it's closer to a particular charge, that their effective, I mean, it will be more effective than if it's little far away, right? There it will be less effective, isn't it? Now you see this chlorine atom is very close to the COO minus, but this chlorine atom, right, you see is almost like 2 carbon atoms away, right? So in this case also it's decreased, in this case also it's decreased, but where it is decreased more in this case, right? In this case, because chlorine atom is more proximal to this COO minus, right? So now where do I have lesser charge? In this first compound, I have lesser charge and maximum amount of charge I see in this, right? So obviously the first rank goes to this, second rank goes to this compound, and third rank goes to this compound. Because these are the most, like this is the most stable conjugate base. So this will be the most acidic. And this is led.
So I have a doubt. Could you
Yeah.
explain again that proximity Cl
Sure.
next to it?
Sure. So what I'm asking, so basically you are going to, this chlorine, which is here, is going to pull the electron towards itself, right? Now this chlorine atom also is going to do, no doubt. But you see here, it is closer to this when compared to this and this, right? This chlorine atom is little far away from this when compared to this chlorine atom with respect to this, right? So where will it have more, where will be more effective? Wherever it is closer, it will be more effective, right? So this is more closer, so it will have more electron withdrawing. Now in this case, little far away, so the amount of positive negative charge is little higher when compared to this case. That's why here in the first case the charge is lesser, and in the second case charge is little higher, and in the third case I don't have an electron withdrawing group. Electron donating groups are only there, so there the charge is maximum, least stable, least acidic. Yes, understood?
So I have a doubt. So
Yeah.
we only look at the distance in this.
Yes, we in this case it's only about the distance.
So we don't bother about the alkyl group here.
No, like if they, now in this case you see there is an electron withdrawing group, and that only should be given priority. Alkyl groups, yes, they do have an effect, but compared to this, this is going to be this is going to give me a more stabilizing effect rather than a destabilizing effect. In this case, it's purely destabilizing. The third case, because I have only alkyl group, there's nothing else to see. Right? Did you understand?
Yes, sir.
Okay, fine. Let me give you one more question. Say now, if I have okay, now tell me which is a better acid, first one or second one?
First one, sir.
First one. Okay. Fine. It's pretty easy, isn't it? Now, in this case, it's not distance dependent because you have chlorine atom right just next to the carboxylic acid. This carbon is having the chlorine. But in this case, I have 2 electron withdrawing groups. Right? This is, I mean, if I remove the H plus, check for the stability of the conjugate base. Right? So if I just put a negative charge here, and if I put a negative charge here, right? Now you see in both these cases it is decreased because I have an electron withdrawing group, right? But in this case I have only 1 electron withdrawing group. In this case I have 2 electron withdrawing groups, is going to decrease the negative charge on the oxygen, carboxylate ion, right? So definitely this one is a better acid than the second one. Okay, right? Fine. So now so hope you understand how do you decide your acidic strengths based on this. And obviously, hope you remember what is the stability order of carbocations and carbanions, right? Now tell me what is the stability order of carbocations, primary, secondary, tertiary, what is the order?
So order in the sense?
Stability order, stability order. Which is more stable? Tertiary, I mean primary, secondary, tertiary. Among carbocations, which is more stable? Yes, and if anybody knows, anybody can answer. Okay, maybe I have to show you what you saw last class, then maybe it will.
So you're asking in carbocation intermediates.
Yes, in the carbocations. Wait, I think I have to show you, then only you will understand. Okay, so guys, this is what we saw, right? We started with electron displacement effects that class, right? So I told you inductive. This is the first one among them is inductive effect. Now I told you what and all you can see about it. You can see about the stability of charged species. You cannot use this for free radicals because they are not charged, right? And you can look for acidic strengths. I told you how to look for acidic strengths. Basic strengths we'll see. I'll tell you how to do it. But for now, you see what is happening in this compound which is mentioned here. Since you have a polar bond here, right, there is going to be a development of partial negative charges on this, development of partial positive charges on this. All this is going to happen, and as the distance, like as you move away from chlorine, you see the amount of positive charge on this carbon, and this carbon keeps on reducing. Why? As I told you, inductive effect is distance dependent. Correct. Okay, now we took some examples, right? I told you. And what is the criteria for stability? Stability criteria is more and more charge, less and less is stability. These two are inversely related, right? Okay. Now, and I told you there can be two types of inductive effects. One is what is called as plus A effect. Another is what is called as minus A effect. Now, plus or minus is always with respect to carbon, right? Whether whether you're increasing the electron density of carbon or whether you are decreasing the electron density on carbon, right? So obviously, if the carbon atoms are attached to an electron withdrawing group, like say X minus, OH minus, and so on and so forth, right, you will see that the electron density on the carbon is decreasing. So I'll call it as minus A effect, right? Same way, electron donating groups, and I told you what are the examples for electron donating group. The only thing which you have to know now, or as all alkyl groups are electron donating in nature, right? So those will give me plus I effect in the sense that they are going to increase the electron density on the carbon, right? Okay, fine. So I think that's what is mentioned here, right? Plus I, minus I. How if carbon atom attached to electron withdrawing, electron donating, this is how you see there'll be a shift in the electron density. Okay, fine. Then we took primary, secondary. These are, hope you remember, this is a methyl carbocation, a primary carbocation, a secondary carbocation, and a tertiary carbocation, right? Now the stability criteria is lesser charge, more stability, right? Now in this case I have nothing. In case of methyl carbocation, I have nothing. I have no electron donating, not electron withdrawing groups, right? So I cannot, it's just going to be there. Whatever the amount of charge is just going to be there, right? But here in case of primary carbocation, what do you see? There is an electron donating group. I told you all alkyl groups are electron donating in nature. So there is an alkyl group which is going to donate electron to this carbocation, decreasing the negative charge, right? So thereby I would say that the amount of positive charge is decreased. So when I compare a methyl carbocation with a primary carbocation has a lesser amount of charge, and so it is more stable, right? Now when I compare a primary carbocation and a secondary carbocation, now you see in this case there are two electron donating groups, both coming from the opposite sides, right? So the amount of negative charge is still more decreased compared to that of a primary carbocation, right? So secondary will be more stable than the primary, right? Now if you go to a tertiary carbocation, people, right, now you see there are three electron donating groups, decreasing the negative charge on the carbocation. So obviously tertiary is the one which is maximum stable, then secondary, then primary, then your CH3 plus methyl carbocation, right? Okay. Now if the same thing I would have done for your carbanions, now in this case, because of the presence of alkyl groups, they are going to donate electron, no doubt about it. But in this case, since it's a negative charge, the amount of charge is going to increase, Last time, since it's a positive charge, electrons are negatively charged, so decrease in charge. But here, they're already negatively charged. I am donating more and more number of electrons to the carbanion. So in this case, primary will have little more amount of charge compared to the first one, because in first one I don't have an electron donating or electron withdrawing groups, right? And in secondary, 2 electron donating groups increasing the negative charge. In tertiary, 3 electron donating groups increasing the negative charge. So the maximum charge is possessed by tertiary carbanion. Again, lesser charge, more stability, right? So if you look at the stability order of carbanions, this would have been the stability order, right? This would have been the, right? This would have been the stability order, right? CH3 minus is more stable than primary, primary is more stable than secondary, and secondary is more stable than tertiary. Right now, we took various examples here. Now you see, in this case, there was a electron withdrawing group. There was an electron withdrawing group. Again, just like how you saw here, it's going to be distance dependent. Here it's just 1 carbon atom away. Here it is 2 carbon atoms away. So in this case, it's more effective electron withdrawing group, decreasing the charge. That's why you see 1 is more stable than 2. Right. Okay. Next. Same thing, right? Now in this, we just took a carbocation in this case, and we do the same example. And this is what I told you. Right, acidic strength is directly proportional to the stability of the conjugate base. And how did you say the stability based on inductive effect? If the conjugate base is lesser charge, then that is more stable. Right, now we took an example for formic acid and acetic acid. Right, now in this case, you see, I just have to remove the H plus. Now these are the conjugate bases, right? In this case, I have an electron donating group, increasing the negative charge. Here I just have hydrogen, and that is not going to do anything. So the lesser charge will be for formic acid. So this will be a better acid than acetic acid. Formic acid is a better acid than acetic acid, right? Then you can same thing here. You have an electron withdrawing group that is going to decrease the negative charge, right? So again, that first one is more stable. I mean, first one is more acidic than the second one. So I think this is where we stopped, right? So now at least do you remember, people, what do you mean by inductive effect? Yes?
Yes.
No? Okay, fine. You know, why are you facing all these problems? Right? I understand that you have exams and stuff, but yeah, you have to be in constant touch. People, organic is not the one. Like, see, everybody would have understood when I taught you. And I even saw how much the participation was. Everybody was participating. But the thing is, if you are just going to leave it, if you're not going to be in constant touch, organic is not going to be a cup of tea. Let me remind you that, right? You have to do constant problems. You have to be in constant touch with the problems, or else you really will not be able to solve it. Even easiest of questions, you will find it difficult. Okay, right, fine. So we'll move on. Okay. So next, how do you decide basic strength? Actually, there are other acids also, other than the carboxylic acids. Just give me a moment, people. I'll be back. Okay, yes, I'm back. So fine. So carboxylic acids are not the only one which you will see is acidic in nature. Obviously, those are the most acidic in organic chemistry. But there are other species other than carboxylic acid which can be acidic, right? And same exact procedures you will follow for all the things for deciding the acidic strengths. Okay. Now, one of them, right, is our alcohols. Right, alcohols are also acidic in nature. We know what is alcohols, ROH, right? So ROH, again this H plus can be removed to form RO minus plus H plus, right? Now this reaction is a little feasible. Okay, but if you ask me, sir, how much they're acidic, they are going to be very, very less acidic when compared to carboxylic acids, no doubt about it. Okay, I would say even they are less acidic than water. We know water is almost neutral, isn't it? But my ROH is little less acidic than water also, right? Again, depending on the alcohol, but generally, alcohols are less acidic than water. Okay, now same thing, right? Now, whatever you did in the case of carboxylic acids, you checked for the stability of the conjugate base, right? Now, if you, this is the conjugate base, isn't it? RO minus is it's called alkoxide ion. If you want to know the name, alkoxide. If it's R is methyl group, it's called methoxide. Ethyl group, ethoxide. So in general, alkoxide. Okay, so if you find that the alkoxide ion is stable, then again you say that the alcohol, that particular alcohol is a good acid, right? So again, if I give you an alcohol and an acid, you just blindly say that carboxylic acid is a better acid. Just blindly say. But if I give you say different alcohols, then there'll be a problem, right? Okay, in the sense that if I give you, again you have something like primary, secondary, and tertiary alcohols, right? Say for example, if you had CH3, CH2, OH, right? And say this is my primary alcohol. Hope you understand how it's a primary alcohol. The carbon containing the functional group is attached to only one other carbon atom. Like last time, how did I tell you in case of carbocations, carbanions? Carbon containing the positive charge or carbon containing the negative charge, if it is attached to only one other carbon atom, it's called primary. In this case, you have to tell like this is CH2, right? So this is the carbon atom containing the functional group. So it is attached to one other carbon atom. So it is primary, right? Okay. Now, if I take a secondary alcohol, your secondary alcohol. Excuse me. Sorry, guys. Okay. So now if you take a tertiary alcohol, it's going to look like this. CH3, C, OH, CH3, and CH3. Right? Now you see in the previous case, carbon containing the alcohol is attached to two other carbon atoms. In this case, carbon containing the alcohol is attached to three other carbon atoms. This is my tertiary alcohol. Obviously, methanol, CH3OH, will be just a methanol. It's not primary, it's not secondary, it's not tertiary. Okay, now use your knowledge, right? Whatever we have seen, and tell me, arrange primary, secondary, and tertiary alcohols in the order of their acidic strengths. Go for it. I'll give you a minute time. It is not going to take much of the time because you know other previous stuff. Same thing. Whenever I ask you about acidic strength, make the conjugate base wherever I have least charge on the conjugate base. That is most stable, and that particular acid is the best acid. Go for it. Yes. Any answers? Yes. Okay. What do you think? Primary, secondary, tertiary. Which is the strongest acid? Yes, I didn't hear anything. Primary, secondary, tertiary. Which do you think is the best acid, the strongest acid?
Primary, sir.
Okay, primary. That makes sense, right? Anybody wants to say oppose or accept the point Rohan said? Quick, guys. Do not wait. I'm looking at the chat box also. Okay, how many of you concur with Rohan or how many of you disagree with Rohan? Okay, so Venetia says primary. Okay, so fine, I got one more vote. Right, okay, so that's correct, right? So primary is the one which is going to be maximum acidic, right? I will prove it how, right? We will remove the H plus from all of these and just check for the stability of their conjugate bases. Okay, so let me put a negative charge, and there is a negative charge. Right, okay, fine. So it's all about whichever is where I'm going to have least charge, that is going to be maximum stable. Right, now you see guys, there is actually alkyl group coming from this side, which is going to increase the negative charge on this oxygen. Right, okay, fine. Now, if you look at the secondary one, you see there are 2 electron donating groups increasing the negative charge on oxygen. In case of tertiary, there are 3 electron donating groups increasing the negative charge on oxygen. Right, so obviously wherever I have lesser charge, that's where I have maximum stability. So obviously I know for sure that primary is the one which has least charge because only that is only 1 electron donating group. Right, so in this case, primary alcohols are more acidic than secondary alcohols, which are more acidic than primary alcohols. Okay, so like, oh, it is just an application of inductive effect, very simple. Again, I can put chlorine atom somewhere, I can just put it closer, put it away, I can put fluorine here, chlorine there, all those stuff I can do. You just have to remember one thing: lesser charge, more stability, as simple as that. Okay, right, now that is one class of compounds, that is your alcohols, other than carboxylic acids, alcohols are little acidic. And one more thing which are little acidic are these terminal alkynes. Right, now we know what are alkynes. Alkynes are the one which has three triple bond C. Terminal alkynes are the one which has the triple bond at the end, either starting or the ending point. Okay, right, now let me prove it to you how that these terminal alkynes are acidic in nature. Right, so what I'm trying to tell you is, if you have a compound like this, and this is the normal ethyne which we know, right? Now this is capable of giving CH triple bond C minus plus H plus. So you see this hydrogen, or say this hydrogen, can be removed. Right. So now tell me guys, how can I prove that this is stable? You tell me, how can I prove it? From all the knowledge you have gained till now, tell me, how can I prove that these are stable? This conjugate base CH triple bond C minus, how is it stable? How will you prove that it is stable? Okay, let me give you a clue. It has something to do with hybridization. Hmm. Any guesses? How will you prove that this conjugate base is stable? Obviously, that means I'm trying to ask you, how do you prove that the negative charge is little decreased? And I told you the clue. The clue is something related to hybridization. It doesn't matter whether you're right or wrong. It's completely all right if you're wrong. Yes, what do you think?
Don't know, sir.
Okay, fine. So tell me, what is the hybridization of this carbon?
SP3, sir.
sp3. How sp3? Calculate. This carbon atom is attached to how many other atoms?
SP, sir.
Correct. You see, it is attached to one hydrogen and this carbon. Correct. So this is going to be sp hybridized. Right. Now, what did I tell you about sp hybridized carbon, sp2 hybridized carbon, sp3 hybridized carbon? What did I tell you about the electronegativities of these carbon atoms? If I have sp hybridized, sp2 hybridized, and sp3 hybridized carbon, which among them is most electronegative?
SP, sir.
sp. Right. Now, how do you tell it? Guys, you are not remembering. That's the point. All these points have already been mentioned. Remember, the amount of s character in the hybridization is directly proportional to the electronegativity. Please remember, right? The more and more is the s character in the compound, or say in the bond, more and more is the electronegativity. Now you see, in case of sp, I have 50% s character and 50% p character. In this case, I would have had 33% s character. In this case, I would have had 25% s character. Right? So you see, maximum s character is there in sp. So that's why it is going to be maximum stable. Sorry, not stable, maximum electron. It's going to be more electronegative than sp2 and sp3 hybridized carbon atoms. Okay, now can you explain me, how is it this stable, this conjugate base?
So what was the question?
Now you understood that sp hybridized carbon is most electronegative. Now, how will you, based on that, how will you prove that this species is little stable?
It has an the carbon has an extra electron, sir. Since CH is more electronegative, it is right to take in the extra electron.
Exactly, that's it. Just this one word, this is going to act as an electron withdrawing group, as simple as that. Since it is highly electronegative, this carbon atom is highly electronegative, it is going to pull the electron towards that, thereby decreasing the negative charge on the carbon. Okay, so that is why terminal alkynes are little acidic, right? Okay, again, they're going to be less acidic, even lesser acidic than alcohols. Okay, so first on organic chemistry, which is the most acidic? Carboxylic acid. Little less acidic is alcohols. Least acidic would be the alkynes. Okay, right? So again, I repeat, why is this more stable? Because this carbon atom is sp hybridized. When you say more and more s character, more and more is the electronegativity. So this group is going to act as an electron withdrawing group, withdrawing electron like this, decreasing the negative charge, making it more stable. Yes, everybody understood why terminal alkanes are acidic? Yes, no? What happened?
So could you explain again the last point? Hello?
Sure. Like, let me actually write it again and then explain. It is a little clumsy. So if I have a terminal alkyne, or let me take another example, that would be better. Say if I had CH3C triple bond CH, again this is a terminal alkyne. Now this is not a terminal alkyne. For example, if I had, this is not at all acidic. Why? Because obviously you see there is no hydrogen atom attached to the sp hybridized carbon, right? So this is not acidic. But terminal alkanes, whenever you see the double triple bond is going to come at the end, yes, that is going to give me an acidic proton, right? Okay, so now what is going to happen? This, if I dissociate, if I remove the H plus, right, now what it's going to be, CH3 C triple bond C minus plus H plus. Okay, now this reaction or this dissociation can happen only if this conjugate base is stable, right? Okay, now how do I prove that this is stable? I have a negative charge. If somehow I can explain how the negative charge is decreased, then it's fine, right? So what I'm seeing here is this carbon atom is triple bonded, right? So it's easily I can say that this is going to be sp hybridized carbon, right? And just now I told you more and more is S character. Generally sp hybridized carbon is highly electronegative, right? So if it is more electronegative, it is going to act as an electron withdrawing group, right? If it is electron withdrawing, what it's going to do, this negative charge, I mean, the amount of negative is going to decrease because the electrons are going to be pulled towards this carbon because it is highly electronegative. Thereby, the negative charge is decreased and this conjugate base is stable and this is a good acid. Yes, now everybody understood.
Understood, sir.
Guys, I want everybody to give me a yes. Everybody understood?
Yes, sir, understood.
Okay, 2. I have, I think, 4 more. Quick. Everybody understood? Yes. Okay, Bavadarani says yes. I still have Rahul, Venisha. I don't know. I think it was Bavadarani who said yes, if I'm not correct. If I'm not, yeah, Bavadarani said yes here. Who was that who told me yes? Was it Divya or Shruti? I think it's Shruti. Okay, got it. Fine. Okay, right. So yeah, I hope almost everybody understood, right? How alkynes are a little stable. I mean, how alkynes are acidic. Okay. Now again, if I put, I can just tweak more questions out of this. If I put, say, if I compare this with, say, okay, so if I compare this with this compound, tell me which is more acidic. This is 2, this is 1. Which is more acidic? This is 2, this is 1. Tell me which is more acidic. Yes, 1 or 2. Quick. You don't have to think this much. Now that you're solved. 2. That's it. Very simple. I have an electron withdrawing group here. Other than the withdrawing group, which is sp hybridized carbon, here also I have that. But here I have just have a, oops. Right? So I have a CH3, right? But here I have a chlorine, which is highly electronegative, which is going to pull the electrons towards this, decreasing the negative charge, thereby me giving more acidic strength, right? So now any questions, people, I see if at all you go to JE level, I can still more actually, screw you up with more questions, right? But for your level, CBSE level, this much is very basic and you need to know this. And I think I have tried my level best to make you understand. And the only thing which you have to do, right, is take your NCERT textbook, go to the general organic chemistry chapter, go to the previous, I mean, not previous year papers, I'm saying the book back exercises and solve it. We almost finished the chapter. We almost the end of the chapter. You can very well solve it. Okay, then only you'll know where you stand, right? Just don't wait for the test to come so that you can test yourself. I know like most of you, I mean, at least 70% of you write the test. rest 30% doesn't even write the test. I really don't know how will you know where you stand. Okay, anyways, so these are the things about acidic strengths. Okay, now let me give a brief introduction about basic strength. Okay, now I'll just give you an introduction and we'll leave you. Right. So guys, now we know that basically we are going to study about the Lewis basis only in this case of organic basis, because nothing is gonna give me OH minus, right? OH minus is not gonna be the thing here. We know what are Lewis bases. Lewis bases are the one which is going to donate an electron pair to some other species. Hope you remember, right? Lewis acid is the one which will accept electron. Lewis base is the one which is going to donate electron. And donate electron pair, I would say that will be a better word. A lone pair is what is required. Okay, fine. It is going to donate an electron pair. Okay, now how do you decide the basic strength? Right. So how do you decide the basic strength is based on this. Basic strength is going to be directly proportional to the availability of lone pairs. As simple as that, right? So if I give you two bases, right? So wherever you see the lone pair is more available, I'll tell you what you mean by more available. That would be a better base. Okay, right. Now, generally, what kind of bases you see in organic chemistry is only amines. Okay, we know what are amines, right? Amines, I can again have three types. Okay, so you have primary amines. It is attached to the NH2 is attached to nitrous attached to only one carbon. Then I can have a secondary amine like this. I just remove one more hydrogen from here and put another alkyl group. This is secondary, and on the last one is tertiary. I removed all the hydrogens, and this would be my tertiary. And you see, all of them are going to have a lone pair on them. Okay, so more and more is the availability of these lone pairs which are marked here, more and more will be the basic strength of all these amines. Okay, now tell me what kind of groups can increase the availability of lone pair on this nitrogen? Electron donating groups or electron withdrawing groups?
Increase it, sir.
Yeah, how will
Electron
you increase
donating, sir.
Absolutely, that is purely logical, isn't it? So obviously, electron donating groups, if you have, that is going to increase the availability of lone pair on this nitrogens, right? So now I think you can now directly say among primary, secondary, and tertiary, which is the most basic? Which is the most basic? Now just you told me, what is that? Electron donating groups if I have, wonderful. It is going to increase the availability of lone pair.
Tertiary, sir.
Absolutely right. You have three alkyl groups which are all electron donating, right? And in this case, you have only two electron donating groups. In this case, you have only one electron donating group. So where do you have maximum availability of lone pair? Obviously in tertiary. So if I go for basic strength of amines, tertiary is going to be more basic than secondary, and secondary is going to be more basic than primary. Okay, so anyways, we'll stop with this for today. Okay, I will continue, right? This is just a preliminary problem. You see, I can actually make it more interesting when I go for resonance. Okay, so anyways, any doubts you can ask me. Is there any question, people? Okay, so I
No
suppose
doubts, sir.
yeah, cool. And guys, I like from next class, see, organic can be made more interesting if everybody participates. It's not like physical chemistry. I can just give you formulas and I can just explain you, right? Organic chemistry, you can just come up with your wild imaginations. I am very open-minded, right? Do not ever think that is going to be a stupid question. Never in your life, right? At least to me, you don't have to do that. I am not going to judge you. Like if at all, I feel that I think Divya, Venisha, like Venisha almost text me at least. But Divya, I think there's a problem with your microphone. I mean, Venisha, I think there's a problem with your microphone. Who I don't want anybody to just chat. I want everybody to unmute yourself and then speak. But if at all you see that the background noises are too much, in that case alone, please use the chat. Right? We can actually make use of this wonderfully. You can ask anything, literally, sir, why not this? What happens if I put a carbon here? What happens if I put a nitrogen here? Anything, literally anything. If you are up for it, I'm going to make it more interesting. Already I'm trying my level best, but if you're going to cooperate, this is going to be really wonderful. Okay, fine guys. Thank you so much. We'll meet again. Yeah, I wanted to ask one more thing. Tomorrow is a holiday, isn't it? For you? You don't have exams?
Tomorrow is a preparatory holiday, sir.
That's what. Tomorrow is a holiday. So can we have class tomorrow morning, or you want to study?
So in the sense, a regular timing, sir.
Yeah, regular time, 7 to 8 morning. Again, if majority of you says that we'll have a class, or else no class. Choice is yours. Quick. You want it or not?
Yes, sir. Fine with it, sir. I'm fine.
Okay. Fine. One vote. Others? If nobody is going to vote, I'm going to keep.
Sir, I'm fine, sir.
Okay, Rahul. Okay, Rahul says study full
Yes,
portion.
sir,
Okay,
we
2.
can have.
So 3-1 Rahul. Okay, 4-1 Rahul. I'm really sorry. Right. So yeah, we are having class tomorrow, 7 to 8. Okay, fine, Rahul. Right. Okay, don't worry. I'll try to leave you a little early. Right. Cool. So yeah, tomorrow you'll have class. You'll get the links. We'll join. We'll see tomorrow. Okay, good sport, Rahul. Nice. Okay, no problem. Very nice. Okay, thank you guys. We'll meet again tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.